this is where we have some fun. Okay? Write it down. What? Okay. Will the chart method work here? Or table method, I guess. I'm sorry. Table method. Will the table method work? It won't. We have to have a polynomial because we have to have that D column differentiate to 0. E to the x, sine of x, those both cycle.
True.
Okay? So we're going to have some sort of system. Okay, try that. Okay. So, we are going to let u equal the sine of x.
Does it matter which?
It probably would not matter, no. Okay, these both cycle, so I don't think it matters which one we pick. But I'm going to choose u to be sine x and dv to be e to the x dx. I remember my negatives better with differentiation for sine and cosine, so that's why I like sine to be u. Okay. So du is and v is e to the x. Okay. So the integral of e to the x sine of x dx is u times v e to the x sine of x minus the integral of v du. Can we integrate e to the x cosine of x right now, like as is? Now, we do have to keep doing this, but it's not going to be infinite. Okay? I promise there's going to be something we can do algebraically to help us out. Okay? But we are going to have to do this again. Okay? So, for e to the x cosine of x dx, it is a product in which we cannot use u substitution, so we have to fall back on integration by parts. Just to keep consistent, I'm going to call u cosine of x and dv e to the x dx. Okay. And I put subscripts just because this is like a different round. Okay. So du is what? Cosine of x dx and v.
Yes.
So we are subtracting the quantity for integration by parts for this integral. So uv e to the x cosine of x minus the integral of v du. E to the x times negative. Okay, so you see what's happening. We're getting the same thing. We're just going to cycle through these. Right?
Wait, after a while, didn't they just start to cancel out?
Well, I wouldn't say cancel out, but isn't this what we started with? Isn't that what we're trying to find over here? Okay, so technically we have two integrals with the same thing inside, right? I'm going to go ahead and distribute out this negative. I've distributed out that negative, and what we can do is we can take this right here, and we can add it over to this integral because they are identical. So we can add those two together, and so we can say 2 integral of e to the x sine of x dx equals blah, 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 blah. Go ahead and add that plus c.
Divided by 2.
Yes, and so then for our final answer, we're going to have to divide it by 2. And I'm really sorry, this is a PowerPoint, not my smart notebook, so I can't make this go any higher. So the integral of e to the x sine of x dx, you can either put all of those over 2 or say 1/2 times e to the x sine of x minus e to the x cosine plus c. When you have e to the x and either sine or cosine, this is going to happen. Okay? You will have a problem like this on your quiz tomorrow, so it is essential that you practice this in your homework tonight. Okay? Any questions about it? Okay. This one is not cyclic, but does get a little messy. Do we need integration by parts? You always need to ask yourself, can I use U substitution? Okay? If U substitution is not an option, and there's a product inside of your integral, then integration by parts is a good choice. So, U and dv. Where do we have to put the natural log of x? Which means dv is, I'm going to write x to the 1/2 dx. All right, so du.
Why does that have to be dv?
We don't have the antiderivative for natural log of x.
Yes, we do.
Technically, yes, we do. But it's something that we have to use integration by parts for. So we're not going to use integration by parts inside of our integration by parts. It's easier to have the natural log du. All right, so what's du? And v. Okay. So Bailey, our integration by parts. What do we pair together first?
Just the u and the dv, not in the integral. So just like the same thing of the integral. Square root of x ln x minus integral.
You're saying pair these two together, right here?
These are not square root of x ln x minus the
Mm-mm.
but I don't know.
Look back in your notes. What do you pair together first?
Can you give me a tricky one.
No,
Because it's always the same thing. It's in the integral, just without the integral.
no, it is not.
I started putting, like, you know how people do the line view Z? I'm doing that on my V's to differentiate them from the U's.
Nice.
So, on my quizzes, send the line to me.
Okay.
Problem is I have a lot of notes, but I have so many notes that I was taking them and I was just copying down what was up there without having to actually think about it. So I don't know.
Okay. Tyler, could you please help them out? What do we pair together first?
Wait a second. UV.
U times V minus the integral
I just think about what
of V du.
Extra negative. Oh.
Okay, obviously that is not pretty right now.
But
How can we rewrite x to the 3/2 times 1 over x? X to the 1/2. Because this is like x to the negative first. You could, okay, two ways to think about it. We're dividing, so we subtract 3/2 minus 1 to get our exponent. Or we think of that as x to the negative first, and we add our exponents because we're multiplying. Minus 2/3 times this becomes x to the 3/2. So I'm going to rewrite that as 4/9. So we have 2/3 x to the 3/2 natural log of x minus 4/9 x to the 3/2 plus 6.
I feel like the ones on our quiz are going to be harder than this.
Fine.
is it not quiz?
So is that 4 random questions?
Also, the little board thing is fine.
I feel like even
Thank you.
when I understand concept, I do really bad in the test because it has so many rules in it that I don't remember from like other professors. It's like harder than the reviews.
Your questions are typically modeled like problems that you have seen. Such as in your homework that I assigned, where you practice these skills.
Not worried about the skills, I'm worried about like the ones where it just kind of comes up and it's like a bunch of crazy numbers. Because that seems to happen a lot. And I get frustrated by the big numbers.
I think I'm doing it wrong and then I have to erase everything and do it again and get the same numbers and just.
Never finish.
So here's the deal. Tomorrow's quiz, you don't actually have to evaluate any of the integrals that you take. You just have to take the integrals. And that's going to save you stuff.
Is there a reference sheet on your website for true rules for those of us who have forgotten?
No, but there is a reference sheet in your book for trig rules. The page number in section 8.1 that I gave you. In section 8.1, there is a list of every single antiderivative rule.
Have you seen the Jimmy Neutron episode where the supervillain is the guy that never can finish anything? So they find him by like bottom shelf half eaten donuts and stuff, and they have to exploit the chink in his
I don't
armor.
watch Jimmy Neutron.
You should.
Well, that guy is me because I never finish anything.
He just like doesn't finish any of his stuff. Like even his big super suit, like is the bathroom. That's what I just beat him on time.
Okay, so don't do the whole.
That guy is me.
Let's see. Didn't clear out my answers. So let's just talk about this one up here. Okay, ignore this.
So we're not fixing.
No, I don't want you to. No, I don't want you to do that. So I didn't clear it out. So if we have f of x cosine of x dx, okay, and this would be our integration by parts setup, how do we know what f of x is? There will be one multiple choice, at least one multiple choice question on your quiz. The model's kind of like this, or like the one that we did at the beginning of class. Yeah. Which is why we talked about both of those. Yes. Okay. So based off of where like the cosine and sine are, is f of x u or is f of x dx dv? U is f of x and dv is cosine of x dx, which means du is f prime of x and v is sine of x, right? Okay, so in our integral, since we have 6x squared sine of x, what is 6x squared? That is du, which means u is 2x cubed. Very nice.
What class were you doing
So everyone answered B, the right answer? Like a year ago.
Oh, okay.
All our students also get this right.
Mm-hmm.
We only have 7.
What?
We only have 7.
No, I actually had 9. Okay, so let's talk about your quiz tomorrow. Your quiz tomorrow is going to cover 8.1 and 8.2. So, like the arc tangent, arc sine rules, you're going to need to be able to recognize. You need to be able to recognize when you need to use u substitution. Obviously, I should probably talk about that first. Okay. If you have an improper fraction, dividing it out and then taking the antiderivative. Okay. Completing the square and the denominator to make it look like a arctangent arcsine rule.
I used the wrong phrase. I meant to say trig identities.
Trig identities. Trig identities should be in one of the covers of your book. Let me
This one, I think I kept mine, but
on the first page in your book, it's on the back. Along with the unit circle. Okay.
Do you have a unit circle quiz?
You want one?
Sure. Can be graded.
I would need more response.
Okay, so this is your homework. It's a lot of random numbers, but it's the ones that I want you to do. It's on your gold sheet. You can just look at your gold sheet for the homework. I'm going to give you time to work on it. That way, if you have any questions on this material or 8.1 material, we can work on that at this time. I don't have a review for the quiz. You're just going to have to look at your homework, and that is your preparation. Okay? I'm going to do that every once in a while because next year when you get to college, you don't get quiz reviews. You just get quizzes. Okay? Hardly ever do you even get test reviews. You just have your homework. So I want to kind of get you ready for that. All right? We've only gone over 2 sections. All right? I don't think they've been overly strenuous sections to where you have a lot to remember. All right? It's just deciding which method to use. Okay? Yes.
I think I killed the fly, but I cannot.
You did
He
not.
just flew over there.
What?
Sorry.
Liar. There really was 2.
Yeah, you didn't realize it's a fly.